That was creepy as fuck. You know, people in middle school used to say that my eyes were get really, really big. And I realize now they really stick out when you, yeah. Hmm. Nuts. Absolutely nuts. He is still annoying. Okay. I'm gonna get some water. I'm gonna text my girlfriend good night. I'm gonna start working on this notification system. No editing. No format. If you're wondering, I'm pretty much talking to myself all the time. So this video's while I'm recording, I'm talking to me most of the time. So the design. The idea for this project is, and I probably should get like a draw.io. I kind of hate draw.io though, because I found something called draw SQL. And draw SQL looks so good. Then I saw draw.io and I was like, this does not feel as good as it should. But let's call it, what am I gonna call it? Let's call it Money Roundup. I don't know why that's relevant, but yeah, Money Roundup. I'm gonna fuck. Money Roundup, blank diagram, create, use root folder. Yes. About Google Drive? Sure. Which drive is this? This drive. Ooh, okay. All right, so the idea is to put some text. So the idea, and I'll make this bigger because I have to actually select everything. All right, so I'm gonna make this left justified. I wish it wasn't in the center, but that's whatever. So the idea is this. And of course, it does not stick. Hello? I can't. Okay. All right. Oh, wait, what does that do? Oh, no way. Cool. Okay. I'll make it bigger later. Pause. So the idea is to send an email notification to my personal email about how I spent money the day. Right? Okay. This is the project. That was my best friend Tyler that I just got a text from. My phone's not on D&D anymore. All right, recall this. This channel is about more than just coding. It's really about becoming great in all aspects of life. So that means physically, financially, mentally, and career-wise as well. And so this involves not just like coding, as I said, but I'm doing more than that. And so getting good at coding helps me financially because then I can make more money. And the higher my income, the better. The easier it'll be to pay down debt and to get financially fit. As far as physicality goes, I went to the gym yesterday. I went to the gym on Thursday. Did I go to the gym on Thursday? Probably not. When did I work out? I think I went on Wednesday. I skipped Thursday. I skipped Friday. I went yesterday. I didn't go today because it's Christmas. I have a chance to go. It's only 6 o'clock. I can probably still go. But, probably go tomorrow. What did Alex Mosey said? You want to stay poor? Start tomorrow, right? Start tomorrow. Anyway, so the base level design for this thing is that my email lives here. I'm going to use a double click again. We're going to have a say sending. I have a sender service that actually sends the emails. And then we'll have a processing service that, and I'll make another list here. I like circles as functions. Let's do functions. What are your functions and requirements, sir? We fetch. I say fetch. Yeah, fetch and process financial data. I think using Plaid as in the API for fetching like data. Like if you ever use Plaid to connect your bank to an app, I'm hoping to connect my app using Plaid to my main bank account, which is Chime, and using that to fetch my transactional data of that day. Now, what's interesting is that Chime, the data that gets pulled is also available. What am I saying? I currently use Rocket Money, used to be Truebill, to track my expenses. They can track money spent on my credit card and on my checking account. So I'm hoping I can do both, but we'll see. And then we're going to connect the two with a message queue. And our sender service will essentially just take whatever's sent in the queue and send it to my email. So we'll do one of these. Okay. And the goal is just to connect all these pieces together using the queue. Okay. I'll just say broker. The broker the processing service will populate the broker. The broker will then hold the message for the sender. I don't have any methods for retry built in. I probably should, but I don't currently. That's fine. That's the main design. I'm gonna look at getting set up with Plaid today, and I'm gonna use a broker. I think I'm gonna use Redis. Redis has been tried and true. I think Kafka is like strict. I think I read an article actually. Let me pause. I read an article actually about the difference between Kafka and Redis, and why Kafka is better than Redis in some respects. So I want to make decisions based on that. I think my use case is simple enough where it won't really matter, but I still want to know. So the two things we're going to accomplish today is figuring out the setup with Plaid, and then the setup with either Kafka or Redis. And then the next session, we'll start with the sender service, so pulling a message from Kafka and then formulating an actual email to be sent to my inbox. Yeah, so let's get to it. Let's take a look at Plaid. Plaid is a service. I'm looking at Plaid. Yeah, FinTech Solutions, Plaid. Ooh, for developers. Quick start. What's this?
Plaid provides you with a single set of endpoints to help you build powerful financial services. Whether it's talking to identity verification sources around the world, retrieving income information from payroll providers, or connecting to thousands and thousands of banks on behalf of your users, Plaid will let you query and receive data in a consistent manner. So you can use Plaid for everything from account verification to approving customers for lines of credit to building some pretty great personal finance apps. You can get started with Plaid by signing up for an account on the Plaid dashboard. There you'll have access to up to 3 different environments. The sandbox environment deals completely with fake data and is the best option to use when you're first starting out.
Okay.
Development gives you access to real data at real banks, but for a limited number of accounts. It's best to use this with a handful of trusted testers. And production gives you unlimited access to real data, but you'll be billed for your usage. You may not have access to this right away.
No.
To talk to the Plaid API, you'll be making calls from your application server. Nearly every call you make will include your client ID and secret, so we know it's really you. You can get this information from the Plaid dashboard, and the Plaid SDKs can simplify this process for you by including this data with every call you make.
Okay.
On the client, your user will do the work of signing into their bank, selecting what accounts to share with you, and giving Plaid permission to access their data.
Okay. One thing I think about is authentication, right? So, what am I saying? Once we authenticate once, so do I need a website to authenticate? Or maybe not, I don't know, maybe I do.
This is done through a UI widget called Link that handles all the heavy lifting for you. So the general process for connecting to most Plaid products looks like this. When your user is ready to connect your app to their bank, your server will talk to Plaid to generate a link token. You'll do this by sending a call to the link token create endpoint and passing in some information about how you'd like to configure link.
So the user, your client, the client meaning my applicant, I'm the client, I'm asking data, I'm the client of the auth endpoint, I think. English, products, auth and identity, country codes US, the webhook, there's a callback, I think, auth, automated micro deposits enabled.
Such as what products you want to require, what language to use, and often some product-specific information.
Okay.
What you'll get back is a link token. Send that token up to your client. From there, you can use Plaid's client-side library to initialize link. You'll pass in the link token along with some methods to call when the user successfully completes link or exits out early. Once you've done that, you can open up link to start the connection process. At this point, your user will sign into their bank, select what accounts they want to share with you, and possibly perform other setup steps depending on the products you're using. When your user is done connecting to their bank, you'll get back a public token. This is a short-lived, single-use token that has only one purpose, and that's for your client to send it down to your server, where you can then exchange it for an access token. You'll do this on the server by making a call to Item Public Token Exchange. Send over the public token from your client, and you'll get back a persistent access token. Save this access token on your server.
So it's a temporary access, so our server has some time to grab the more permanent
You'll
access
use this
token
whenever you need to request data from this financial institution on behalf of this specific user. At this point, you can use the access token to start making calls against the Plaid API. This might include the auth endpoint to retrieve the user's routing and account numbers, the transactions endpoint to get a list of recent or historical transactions for this account,
That's what I need.
asset reports to help you with loan underwriting or decisioning, or one of the many other products Plaid supports.
Very good.
Plaid can also send you webhooks so we can proactively let you know about important updates, like if there's a problem with an account or if more data is available for you to fetch.
I need to learn more about webhooks too. Like what the hell a webhook really
And
is.
be sure to visit the Plaid dashboard where you can get information like your application's overall usage, the status of specific bank connections, or reports on individual API calls to help you with debugging and support cases. This has been Getting Started with Plaid in 3 minutes. If you want to know more about developing with Plaid, check out our full-length tutorial
My
that
hair
shows
is
you how to
so
get started
thick.
with the working sample application. Visit our YouTube channel for more videos like this one, and be sure to visit our documentation
Where's
for
that
more
video?
details about all the Plaid products. Happy coding!
What? Where was that video just now? It disappeared for a second.
Plaid
That
provides
was weird. Anyway. Okay. So our app needs the client ID and secret. We're going to be mostly in sandbox and development. Up to 100 live credentials. So I'm pulling it once a day. So that's 30, 31. As little as 28, as much as 31, right? Okay. So we just need API keys, right? So we just need, so we put in our env file a Plaid ID and Plaid secret. What does Ende want from me? Oh yeah, my girlfriend. Oh my god. I don't know why social interactions bother me so much. They bother me so much. Like I love Ende, but the thought of hanging out with anybody right now just bugs me. Like social anxiety is real. I get anxious. I don't know. It's like it could go wrong or something. Like, am I nuts? I'm just sitting here just like, why would I want to hang out with someone? It's like, hang out and do what? Spend what time and what money? I don't know. Most of my friend hangouts are over video games too, so maybe I can just tell them about that. But it just freaking freaks me out sometimes. Okay, well, they're cloning a repo and starting it up. And they're saying to open a shell. It's something running on the front end. Sandbox credentials. Oh, I don't use those anymore. Create a first item. How it works. Link create to create a link token. On success, callback. We exchange it for a real token. Then we request for items. Ooh. So they have their own library for this. It's very simple. A route that says create link token, post request. Grab some user, grab their ID. Why do we need their ID? Client user ID. Wait, do we search in our database for that? On the front end, there's a token for actually signing in. Okay, so this might include, well, a user has to register, right? So if I am the user, I'm trying to access my bank data through Plaid. I mean, I say Plaid, but really it's any, if Chime has their own API, I might just use that. The Amazon Chime API references, what does that mean? Oh, Amazon's like video thing. They have one? I can get a key. Oh, this is not what I thought it was. Is banking at all? No. They have an API? They don't have an API. I'm sorry, I can't. And they wants to hang out tomorrow and do what? Do what? Where? And spend what time and what money? I don't hang out with my friends. People run down this hallway. Like they sprint. Oh. So I guess someone has some kids that they play around in the hallway. All right, that's whatever. I didn't want to hang out. Doing what? I don't hang out with people. I really don't. Like, it is so weird. I don't plan hangouts. I still don't want to do that. I don't. Like, I can't lie. I can't lie. I do not want to hang out with anybody. Even Jasmine, I only do it with Jasmine because, like, she's my girlfriend. Like, I like hanging with her. I can completely disassociate. With Ende, it's like I have to be talking to him all the time. Oh, social anxiety is real. It's real, bro. I love Ende and I want to hang out with him. I just can't bring myself to do it. Are they using TypeScript? Oh my god, they're using TypeScript. Okay. Anyway. Let's see. Da-da-da-da. Crazy. Crazy. Okay. All right, well. With Plaid, it seems like I need a front end of some type. But looks like they give us one already. So set up without Docker. Ooh. I want Docker. I use Docker all the time. Okay. They have a Postman collection? That's crazy. So I need API keys. Let's do that. Let's get it going. Oh, this is funny. What's my name? Edison Codes. I'll just say archives. Fuck it. I can make a password because I don't really care about having a strong one. Or I want to have a strong one. I don't care about memorizing it. Nope. Custom plan. Nope. Create account. Verify email. Oh my god. They an active user. Yes. Let's log in. Oh. Got redirected. My phone off again. Why? I have a hard time talking to my girlfriend. I don't know what to talk about. I don't know. I'm in my head. Anxiety. I don't want to leave my house tomorrow. I don't want to leave my house tomorrow. At all. Like, let me tell you, it's not about end day. I had the same thing with Jasmine too. I do not want to leave my apartment. I don't want to leave. I don't want to do anything. I don't want to have to, like, get dressed and be anywhere. Like, I don't want to do that. But being in here, I swear to God, being in here and not recording, being in here and not doing something is, you know what I mean? Yeah. Being in here and not, yeah, I don't know. Do I have keys yet? Team settings, keys, client ID, web development and sandbox secrets. Copy. I can rotate them. Ooh. Crazy. Crazy. You have an API, default API version. Allow redirect URLs. Members, just me. OAuth institutions, webhooks. Create a webhook. Event. No options. Okay. Because I should look more into that eventually. A webhook is an HTTP request used to provide push notifications. Plaid sends webhooks to automatically inform you about changes to Plaid items or status of asynchronous processes. For example, Plaid will send you a webhook when an item is in error state, or additional data available, or when a non-blocking process is complete. To receive webhooks, set up a dedicated endpoint on your server as a webhook listener that can receive post requests. Then provide this email. To Plaid as. In the next section, oh, cool. So a webhook is a listener that another service can send you information. So, okay. What? Oh. Thanks, Plaid, for the welcome. Much appreciated. I don't know why I'm so afraid to hang out with people. I swear to God. End day of all people, I'm just like, I don't know how long it's gonna take. And I might want to go home. And how I tell them I want to go home. Like, you know what I'm saying? Am I weird for that? Slightly. I'm not working. I need to be working. I don't sit there. It's late over there. It's like midnight. Yeah. It's like past midnight, almost 1 a.m. Uh, if anyone wants to come over here and just like eat at my time, I'm not a fan of that. You know what I mean? Oh. Again, I have nothing against Ende, like at all. Just people in general. I'm just like hanging out. It's like, oh, it makes me, you know. It's so I would probably whitelist these. Oh, but they can change. Verification or retries. Best practices. Okay, so webhooks are a thing. So the idea here, oh, this is with Docker, non-Docker. Both their checking account and their savings account, a single item will be associated with both these accounts. Oh, okay. So an item is a login that can contain many accounts. Okay. But the flow is like this. A user wants to connect their bank. We get a link token to give the user access to log in. They log in. Our server then sends a public token to open link for the user. They give us a temporary public token. So they verify credentials, okay? They verify credentials with our bank. And our banks probably use another provider or their own provider. They have an endpoint available. Interesting. But only because of how they play nice. That's crazy to me. Unclear. But teaching ain't it. Damn. What Tyler joined tech? That'd be kind of crazy, bro. Kind of nuts. Okay. So call item public token exchange. Exchange public token for permanent access token and ID item for the new item. Legacy libraries or current libraries. Same code, just they're literally like creating a link token with like keys. But passing it as a request, everything gets put in there. The user equals client user ID. Huh? Searching for the current user. Searching in our database? I don't understand. Huh? I don't Okay. So Plaid's supposed to have some kind of front end that a user can log into. So Plaid's not really about programmatic access. Plaid's more about like end user access. Okay. So I would need to have a small front end. I say small, minimal front end to allow me to log in to Chime Bank, giving my service long-term access to my bank information. Okay. And so once my service has access, but I need that front end. I can't just code. I can't codify. You know what I'm saying? Okay, so here's what we know so far. Our service ultimately sends out an email. The sender is the sender, the broker is the broker, processing is processing. Processing needs to have its own front end, and it can be small to allow me to log in. So I'll say front end for me to log into Chime. Once we've logged in, we give my service access to now pull Chime's data. Once it pulls Chime's data, it'll run whatever calculations it wants, sends that to the broker formats the email based on the data coming in. Or I should say, the email for this specific type of notification takes the data from the broker. Okay. So how do we get this done? Well, it's looking like in terms of broker, or in terms of the processor, we need to first get the Plaid service in a repo downloaded and running and available for me to log into. Okay. And then once I can log into it, then we need to test out pulling data from the Chime bank. Once that's done, then we can worry about the broker and the sender, then getting it to my actual email. So let's talk about the broker. Let's look up message brokers. I say Python. IBM has a video. IBM has a lot of data on some of this. What is a message broker? Enables apps, systems, and services to communicate with each other, blah. Our software modules within messaging middleware, message-oriented middleware, MOM, okay. This type of middleware provides developers data between applications and components so they can focus on core logic. It can serve as a distributed communications layer that allows applications spanning multiple platforms to communicate internally. Message brokers can validate, store, route, and deliver messages to the appropriate destinations. They serve as intermediaries between other apps, allowing senders to issue messages without knowing where the receivers are, whether or not they are active, or how many of them are. This facilitates decoupling of processes and services within systems. In order to provide reliable message storage and guaranteed delivery, message brokers often rely on a substructive or component called a message queue that stores and orders the messages until the consuming application can process them. In a message queue, messages are stored in the exact order in which they are transmitted and remain in the queue until receipt is confirmed. Receipt. Asynchronous messaging, 1511. It's in a video, I guess, somewhere. Click on it, what happens? YouTube. No. Okay. Messaging refers to the type of inter-application communication that message brokers make possible. If it prevents the loss of valuable data, it enables systems to continue functioning even in the face of the intermittent connectivity or latency issues common in public networks. Asynchronous messaging guarantees that messages will be delivered once and only once in the correct order relative to other messages. Message brokers may comprise queue managers to handle the instructions between multiple message queues, as well as service providing data routing, message translation, persistence, and client state management functionalities. Message broker models. Message brokers often offer two basic message distribution patterns or message styles. Point to point. This is the distribution pattern utilized in message queues with one-to-one relationship between message sender and receiver. Each message in the queue is only sent to one recipient and is consumed by only once. Okay, so you can send one to one. It's sent to only one person and can only be consumed one time. Okay. Point to point is called for when a message can be acted upon only one time. Examples are suitable use cases for this in style payroll, financial transaction processing. So point to point is okay, cool, okay. Both senders and receivers need a guarantee that each payment will be sent once and only once. Suppose so. The producer of a message publishes to a topic, and multiple message consumers subscribe to topics from which. So our use case is point to point, right? So ours is point to point. Let's make a note of that. This will be a point to point broker. So point to point broker, since the sender service is the only thing listening. And the brokers would, okay, so this is a classic microservice architecture, right? Classic. Freaking classic. The sender service. Anyway. Well, let me call it out now while it's in my head. So I thought about this and I said, well, if our access gets weird, right? Or if there's an error on accessing the Chime data, we need a webhook that will send an email to me saying that, oh, we can no longer access your Chime data, or something's wrong with the account setup. Please go log in. So let me make another note here. This is a functionality piece, right? I should say webhook to the processing service. Processing can serve as the main API too, right? The main API is where we're gonna log in, set up it, and then it'll also run and do some. Yeah, okay. Yeah, that's fine. I'm okay with that. And this goes into processing, right? Yeah, I'm gonna actually delete this line and make it go from here to here. And I'll also make this go from here to here as well. By the way, okay. Web hook for account issues. We're gonna schedule it, but scheduling it is its own thing, right? So we could probably schedule it with cron, or you can use an actual, like, usually batch processing is a scheduler. So something like Airflow, you can schedule stuff like that. DAG is something like, I don't know, something of that nature. We'll take a look at the specifics later. Okay. This is feeling good. It's feeling like it's coming together a little bit, right? What else? So we want pub sub. Message brokers versus APIs. That's a good one to do. Streaming versus streaming. Use cases. Okay. Orders, payment processing. Yup. E-commerce order. Yeah, okay. Use cases. Got that already. Versus enterprise bus versus APIs. REST APIs are commonly used for communications between microservices. The term REST defines a set of principles and constraints that developers can follow when building web services. Any services that adhere to them will be able to communicate via a set of uniform, shared, stateless operations and requests. Application programming interface denotes the underlying code that if it conforms to REST rules, allows the service to talk to one another. REST API uses HTTP to communicate. Because HTTP is standard protocol, REST APIs are widely known, frequently used, and broadly interpretable. HTTP is a request response protocol. So it is the best user versions call. Okay. The request must be designed to expect an immediate response. If the client receiving a response is down, the sending service will be blocked and will wait. Message brokers enable asynchronous communication between services so that the sending service does not need to wait for the receiving services reply. This improves fault tolerance and resiliency in the systems in which they are employed. In addition, the use of message brokers. Something about this American water, bro. My throat is constantly has phlegm. This guy said, "I will think and let you know." Anything he wants to hang out, he's telling me. Anyway, event streaming platforms, different than message brokers. Whereas message brokers can support two or more messaging patterns, including message queues and PubSub, event streaming platforms only offer PubSub style. Designed for use with high volumes of messages, event streaming platforms are readily scalable. They're capable of ordering streams of records into categories called topics and storing them for a predetermined amount of time. Unlike message brokers, however, event stream platforms cannot guarantee message delivery or track when consumers have received messages. Event streaming platforms offer more scalability than message brokers, but fewer features that ensure fault tolerance like messaging and resending, as well as more limited messaging. Okay. Event-driven architecture. Well, then why would you ever use an event? means you have to have built-in retry logic, right? Because it says there's no guarantee that you'll ever receive it. So why is that okay? I want to learn more about that right now. So why is that even okay? Event-driven architecture is an integration model built around publication, capture, processing, and storage of events or persistence of events. When an application or service performs an action, it undergoes a change that another application or service might want to know about. It publishes an event, a record of that action or change that another application or service can consume and process to perform actions in turn. Event-driven architecture enables a loose coupling between connected applications and services. They may communicate with each other by publishing and consuming events without knowing anything about each other except the event format. This model offers significant advantages over request-response architecture, in which one application service must request specific information from another specific application or service that is expecting a response. Each event architecture maximizes the potential of cloud-native applications and enables powerful application technologies such as real-time analytics and decision support. In event-driven architecture, applications act as event producers or event consumers. An event producer transmits an event in the form of a message to a broker or some other form of event router, where the event's chronological order is maintained relative to other events. An event consumer ingests the message in real time or at any other time it wants and processes the message to trigger another action, workflow, or event of its own. In a simple example, a banking interface might transmit a deposit event when another service at the bank would consume and respond to by writing a deposit to the customer's statement. But event-driven integrations can also trigger real-time responses based on complex analysis of huge volumes of data, such as the event of a customer clicking a product on an e-commerce site generates instant product recommendations based on the customer's purchases. Event-driven architecture messaging models. Event messaging or publish, subscribe. Event streaming. Okay. In PubSub, subscribe, yep. The broker receives a message. The broker receives an event message, translates it if necessary, maintains an order, the item available to describe it for consumption, then deletes them once they are consumed so that they cannot be consumed again. In the event streaming model, event producers publish streams of data to a broker. Event consumers subscribe to the streams, but instead of receiving and consuming every event as it is published, consumers can step into each stream at any point and consume only the events they want to consume. The key difference here is that the events are retained by the broker even after the customers have received them. A data streaming platform such as Apache Kafka manages the logging and transmission of tremendous volumes of events at very high throughput. A streaming platform offers certain characteristics a message broker does not. Event persistence, because consumers may consume events at any time after they are published, event streaming records are persistent. They are maintained for a configurable amount of time, anywhere from fractions of a second to forever. This enables event streaming applications to process historical data as well as real-time data. Complex event processing, like event messaging, event streaming can be used for simple event processing, in which each published event triggers transmission. Like event messaging, each stream can be used for simple event processing, in which each published event triggers transmission and processing by one or more specific consumers. But it can also be used for complex event processing, in which consumers process entire series of events and perform actions based on the results. A series of events. So streaming sounds like a stream, right? It's ongoing. It's not request response. It's not I sent it, you acknowledge, that's it. It feels like more can come out of it like that. I feel like I'm hearing stream, like a river, right? Compared to request response, application architecture, event architectures offer some advantages: powerful real-time response and analytics, fault tolerant scalability, asynchronous messaging. microservices. For implementation, microservices can communicate with each other using REST APIs, but REST undermines many of the benefits loosely coupled. Yeah. Yeah. Anyway, okay. So, for example, when a customer buys something, there are many services that need to know that a customer bought something. So, my question is, I'm probably off camera. Am I off camera? Not really, but really. So, my question is, why would you use a broker anyway, right? So, why would I use a stream? I mean, PubSub for the model. I'm talking about like streams versus non-streams. Does that make sense? Let's say event streams versus, okay, so event versus a message queue. In these cases, architecture, any more IBM articles, a stream versus a queue. What does Stack Overflow have to say about this? In traditional message processing, you apply simple computations on the messages, in most cases individually per message. In stream processing, you apply complex operations on multiple input streams and multiple records, messages at the same time, like aggregations and joins. Furthermore, traditional messaging systems cannot go back in time. They automatically delete messages after they get delivered and all subscriber messages, and also to all subscribed consumers. In contrast, Kafka keeps messages as a pull-based model. Oh, so when you do a message broker, it's sending it to a specific system, and once it consumes it, it's gone. So, for example, if I sent a message to a group chat, and let's say my friend's phone is off, or let's say for some reason he can't consume the message, his phone can't consume it, you can't guarantee that you'll be online. So because we know that our server, we control the server, we control the consumer. Anyway, am I playing it now? I doubt it. Yeah. So streaming is more like sending it out there for it's strictly PubSub, and you can configure how long messages stick around for, and consumers can grab the message whenever, and they want to create complex data. Huh. So we don't have to use Kafka. Kafka seems like an overkill, though. Furthermore, traditional messaging queues cannot go back in time, as they delete them in context of key messages as a pull-based model, or for configurable amount of time. This allows consumers to rewind and consume messages multiple times. Or if you add a new customer, it can read the complete history. This makes stream processing possible because it allows for more complex applications. Furthermore, stream processing is not necessarily about real-time processing. It's about processing infinite input streams, in contrast to batch processing, which is applied to finite inputs. Okay. What about this article? Medium. About this guy. Let's see. Okay. So enterprise messaging and event. Enterprise messaging and event streaming are two technologies you can use to implement asynchronous. Asynchronously coupled, not asynchronous. I'm mumbling because it's me. And these videos have no audience. Yes, some people are watching them, but I'm literally doing this for me, so I couldn't care less about being audible. Okay. When you look at their inner architectures to understand why they exist and what problems they're trying to solve, you realize that these two are complementary technologies rather than competing technologies. In this article, we are going to compare and contrast these technologies across several dimensions. Toward the end, you can see a summary of cases that each technology will be ideal. Now, what's crazy is I'm not taking notes on this. Ideally, in my Notion, I would have a section of like architecture, and have like a section on microservices. But that's a lot of work. I'm not ready for that right now. It's a lot of work to take notes and stuff like that, to be taking copious notes. I might forget. And if I need to look it up, I need to look up a new article. I hear you. A temperature sensor publishes readings to a message system every 10 seconds. A thermostat application consumes these readings from the message system and decides whether to turn off or on the heater. A typical message published looks like this. Sensor ID. Timestamp and reading value in Celsius. Okay. So which sensor in what room? Got it. One way to look at each message makes decisions independently. The messaging approach. For example, if the reader is less than 20, the thermostat turns in the heater. Same logic next time a message comes in. Okay. Even though this is unnecessary, this is how messaging works. Each message is discrete. A consumer can understand messages in isolation, and they can directly act upon them. We can also aggregate readings over a time window to calculate the average value of reading, then make a decision based on that. For example, the thermostat can calculate the average reading over the last minute and decides whether to turn on the heater. The average seems a realistic measure here. The average temperature. Streaming is a good fit here because you're not making decisions by looking at discrete messages. You're trying to discover patterns by looking at an incoming stream of messages. An event is a proper term. An event stream? Or what do you mean by that? In streaming, an individual message doesn't make much sense. You need to aggregate and perform certain operations on them to gain more insight. Messages can be aggregated over a time window or based on a count. Then perform aggregate operations, sum, average, mean, count, filtering, and transformations to uncover patterns. One message, logic, action. Many messages, some logic, some action. Dimension 2, messaging consumption style. Messaging consumption is a destructive operation of messaging systems. Messages are stored in the messaging system until they are consumed, then get deleted to make way for new messages. In contrast, consumers never delete messages in streaming systems. The messaging system removes messages independently from the consumers, irrespective of their consumption status. Huh? In contrast, consumers never delete messages in streaming systems. The messaging system removes messages independently from the consumers. Oh, okay. So basically, the broker is responsible. The queue is responsible for managing messages lifetime, or we manage it and it responds to our config. Okay, got you. That's kind of weird to say. A little bit. Anyway, um, in streaming, access message history. Well, mentally, I feel like I work a lot, and I feel like my work speaks for how much I care about her. But really, I learned a simple line that women want to be loved. Women need to be loved, but they want to be respected. And so I'm learning now that as much as I respect her, that won't replace what she needs is love, essentially. So, you know, I got to make a plan. I got to come back. She has to come back to a bunch of gifts, like Merry Christmas. Like, you know what I'm saying? Like, the $1,000 is whatever, but she should come back to more stuff than that. Just got to find the money. I don't know. Anyway. All right, let's see. In messaging systems, messages are deleted after they're consumed. Therefore, newly joined customers cannot see all the messages. Some pub subsystems can keep messages for an extended period, but that's not the point here. In streaming systems, new and old customers have access to complete history of messages. Newly joined customers can catch up with older messages as they move forward and backwards to read messages. That will add benefits from many perspectives. For example, you can debug a consumer by replaying the messages from the beginning that it had consumed. Apart from that, when a new version of a consumer deploys, it can quickly synchronize to the latest state by consuming the stream from the beginning. So when something goes down, you can catch back up. Okay, cool. For example, new customer can be introduced to analyze past readings and visualize temperature variance. When it deploys, it will consume messages from day one to produce a dashboard. Mention 4, fine-grained subscription messaging. Messaging systems provide a fine-grained subscription to messages with subscription filters. With hierarchical topics, consumers can subscribe to messages that they are only interested in. The messaging system performs event filtering there. Conversely, streaming consumers will receive all the events in a partition. A consumer's logic has to decide which events to process and which events. And I read that in an article once about how when you have a stream, services have to listen for information and decide whether or not to act on it. Whether a messaging queue, whatever comes in the queue, is for you, technically. It's technically already for you. The consumer's logic has to decide, yep, in our example, a thermostat in the living room can tune in to receive temperature readings that only relate to living room. It is made possible by subscribing to the topic temperature rooms living to filter out any unrelated messages. Okay. Dimension 5, message delivery guarantees. Dimension delivery guarantee is another dimension to compare these two technologies. Both have been designed and built to serve different levels of delivery guarantees. At least once, messages are not lost in the event of failure, but any message may be duplicated. Applications need to be designed to ignore or handle duplicate messages. Exactly once, messages are not lost in the event of failure, and each message can be processed individually to prevent possible duplication. Applications reliably know that each message will be processed only once, almost independently of application logic. Meaning that if the app fails to do anything with it, it's gone forever. Okay. Well, I mean, if our email ever fails to send, we'd want the message to acknowledge. Well, the acknowledgement has to come when the email is successfully sent. If the email never sends, don't get rid of that data. Or do get rid of that data and wait for the next week. Right? Let's see. Transactionally coordinated delivery. An application can coordinate the processing of a message with a specific update to an external resource, such as a database. Applications can update multiple resources without fear of them ending up out of step. Based on each other's design criteria, we can come to the following conclusion. Messaging systems are good at handling exactly one and transactionally coordinated delivery use cases, while streaming is good for handling at least once delivery scenarios. Messaging and streaming are complementary technologies rather than competing technologies. They serve different purposes in the messaging industry. Deciding which technology to pick should be based on the use case. Example, I hope you can use the above dimensions as guidelines. The following figure just provides a summary of the decision we have had so far, of the discussion we've had. I cannot read, bro. When you're looking at building a messaging solution, you can consider a general purpose message broker like Apache, ActiveMQ, or RabbitMQ. Apache Kafka and Amazon Kinesis are good candidates for developing a distributed, durable, and highly scalable event streaming solution. Okay, so what about Redis? Redis is in-memory data store, and this is the ebook. It's Redis streams and Kafka. Let's look at Redis anyway. I'm interested in Redis as a clustering persistence use cases. Ooh, they use Fast API. Look at that right there. Download stack. Some Docker. So Redis is not a message. Is Redis a message queue? It's a key value store or a metis or or message broker. Redis streams, the best communication channel for building streaming architectures. Log-like data, persistent data. What? So RabbitMQ is what? Based on configuration resources, ballpark here, messages per second, both persistent and transient. So do I even need a queue? We don't really need a queue, but getting one set up would be ideal. We don't really need a queue, I don't think. I think that since this is such a small system, if we don't expect this to scale anywhere, then we're fine. But if we want to add, n length emails, then we would need some kind of queue and process them asynchronously. Otherwise, we have to wait for each one to go, and that could take however long, especially if this scales out any further than that. Right? One-to-one. Open source through both point-to-point, which is what we need. Kafka, created by LinkedIn. Oh, word. Pub sub, data persistency. It's only one to many. Does not persist one to one. Crazy. Redis. Basically, no. It's an in-memory data store. No volumes. Real-time processing. Redis was not one-to-one. However, since version 5, PubSub, people are using Kafka and RabbitMQ, I guess. So short-lived. Redis memory short-lived messages where persistent is not required. Because it provides extremely fast service and memory capabilities, Redis is a perfect candidate for short retention messages where persistence isn't so important. Some loss. Streams one to many. Okay, so what is I think RabbitMQ is a good choice here then. Memphis. Oh shit. I don't really care about streams. I want to look at this RabbitMQ video.
What is RabbitMQ and what makes it one of the most popular message brokers out there? My name is Whitney Lee. I'm a cloud developer here at IBM. Before I dig in, please don't forget to hit that subscribe button.
I will not.
Let's travel back in time to the days of monolithic architecture. Back then, application components were tightly coupled. That means they were directly connected. So in a simple retail application, if we had a checkout service and it needed to communicate with an inventory service, that would be done directly usually through a TCP connection.
TCP connection?
So this had some limitations. As soon as the checkout sent the message, it would need to hear a reply before it can move on to the next task. Or worse, if the inventory service went down, it would try over and over again until it was able to make that connection. Or if a lot of checkouts happened at once, the inventory service wouldn't be able to keep up and the whole system would get bogged down. So that's why message queues were created, or message brokers. And a message queue sits in between the two services that need to communicate with one another. So with a message queue, a checkout can add a message to the queue and then immediately move on to the next task. And then similarly, the inventory, when it's ready, can consume from the queue, process the message, and then immediately consume the next message. So this is going to decouple the two applications. A message broker is also going to help with scalability. So the inventory, if a lot of checkouts happen at once, the queue begins to fill. You can have more than one consuming service, more than one inventory in our case, to read from the queue to handle the amount of workload that the checkout is producing. And that's going to make the system more scalable.
Crazy.
Another big benefit of message queues is that the queue itself can sit on its own machine.
I'm gross.
So in that case,
No
it
judgment,
can
though.
offload some of the work that's done by the web application and make the whole system more performant. So let's talk about RabbitMQ. RabbitMQ is an implementation of the AMQP message model. That's Advanced Message Queuing Protocol, and specifically version 091. So with this type of message model, the producer, in our case, the checkout, the service that produces the messages, instead of producing directly to a message queue, it's going to produce to an exchange. So you can think of an exchange as a post office. It's going to receive all the messages and then distribute them according to how they're addressed. An exchange could be connected to many queues. In our case, we're going to do 2. And then the queues are connected to the consuming services or consumers. So we'll have one called inventory, and then we'll do one called shipping. Might need to consume from a checkout. So the checkout will send a message to the exchange. The exchange is connected to queues through connections called bindings. And these bindings can be referenced by the binding key. And then our consuming applications or consumers, consuming services, those subscribe to the queues.
Why would
So
I don't want to write notes today. I don't want to write notes. I don't want to take notes. If I don't take notes on this, bro, I'm literally going to be like, just getting started. This is whatever. So if I go, we use Sui, Wiki, Codebase, Backend. We title it what? Architecture, right? You want bullet points? You want like sections? There's sections. Oh, what? Now what? Oh, that's pretty sick. So I can look at asynchronous. I can look at, we can give a section on message queues then. Well, we can say decoupling. We can put one that's heading 3 for message. I'll say messaging queues and / brokers. Something like that. I'll start with something simple. Tab doesn't work here. It's a list. List. Create database view. Data source. I don't want that. It's a list though. Numbered list, toggle list. Yeah, if I want toggle list. Okay, this is message queue. This is Rabbit MQ. So I'll list a couple bullets here. So there's other messaging queues and brokers for asynchronous decoupling. So we're basically, I guess we're saying this is asynchronous architecture. Asynchronous architecture is really about decoupling, but there could be more involved. So I'm leaving it sort of like in one area. I can turn this into a toggle, right? Oh. Okay. And this can go underneath this as well. Oh, look at that. Okay, cool. Okay. And notice, right? We used some awareness there. I said I didn't want to take notes. We'll do it tomorrow, knowing damn well that doing it tomorrow will not feel any better. Feels better to put it off, sure, but doesn't feel better, kind of crazy. All right. So, and there's a couple we can use here, but to take notes specifically on like RabbitMQ, it's a message.
This is the message broker here, this part of the system. One thing that's great about this message model is the flexibility with which the messages can move through the system. And that flexibility is largely in part to the different types of exchanges available. So the first type of exchange that the system can do is a fan-out exchange. With a fan-out exchange, checkout will produce to exchange. The exchange will duplicate the message and send it to every single queue that it knows about. Or we have a direct exchange. With a direct exchange queue, exchange can the amount of workload that the checkout is producing, and that's going to make the system more scalable. That's done by the web application message model. That's Advanced Message Queuing Protocol, and specifically version 091. So with this type of message model, the producer, in our case, the checkout, the service that produces the messages, instead of producing directly to a message queue, it's going to produce to an exchange. So you can think of an exchange as a post office. It's going to receive all the messages and then distribute them according to how they're addressed. An exchange could be connected to many queues. In our case, we're going to do 2. And then the queues are connected to the consuming services or consumers. So we'll have one called inventory, and then we'll do one called shipping. Might need to consume from a checkout. So the checkout will send a message to the exchange. The exchange is connected to queues through connections called bindings. And these bindings can be referenced by the binding key. And then our consuming applications or consumers, consuming services, those subscribe to the queues. So AMQP, RabbitMQ, this is the message broker here, this part of the system. One thing that's great about this message model is the flexibility with which the messages can move through the system. And that flexibility is largely in part to the different types of exchanges available. So the first type of exchange that the system can do is a fan-out exchange. With a fan-out exchange, checkout will produce to exchange. The exchange will duplicate the message and send it to every single queue that it knows about. Or we have a direct exchange. With the direct exchange, the checkout will produce a message, and then that message will get a routing key. So with a direct exchange, the routing key is being compared to the binding key, and if it's an exact match, then the message will move through the system accordingly. Next, we have a topic exchange. With a topic exchange, we can do a partial match between the routing key and the binding key. So if we had a routing key on this message called ship.choose, and the binding key was called ship.any, and the exchange type was a topic exchange, that message would get routed through to this queue. There's also a header exchange. With a header exchange, the routing key is ignored completely, and the messages move through the system according to the header. And then finally, we have a default exchange. This exchange is unique only to RabbitMQ. It's not part of the AMQP message model. So the default exchange is also called a nameless exchange. And with the default exchange, the routing key, let's say the routing key of this message is INV. The routing key is getting tied to the name of the queue itself. So if this queue is named INV, then the message would route through to there. So there are a couple main benefits of RabbitMQ right now with the architecture, and one is the tremendous amount of flexibility you have moving messages through your system. In fact, they say you can design your system with whatever you want, the sky's the limit, and then later configure RabbitMQ to work with your system, as opposed to needing to know RabbitMQ's location. It's not part of any. And the exchange type was a topic exchange. That message would get routed through to this queue. There's also a header exchange. With a header exchange, the routing key is ignored completely, and the messages move through the system according to the header. And then finally, we have a default exchange. This exchange is unique only to RabbitMQ. It's not part of the AMQP message model. So the default exchange is also called a nameless exchange. And with the default exchange, the routing key, let's say the routing key of this message is INV. The routing key is getting tied to the name of the queue itself. So if this queue is named INV, then the message would route through to there.
But, so there's a binding key that connects an exchange to a queue. And so when you send a message out, the routing key is it routing or routing? Oh, it's root. So routing key that matches the binding key. And then for the fan out, it's all the above. For a header, it's just the header.
So there are a couple main benefits of Rabbit.
Okay. And then for default, you can name a queue specifically, and it goes to that queue. We ignore the binding key. So same thing. It's the same thing. So default acts like a direct topic, like a direct message. So the default acts a little bit like direct. It's funny how there's not a single promotion, and DoorDash keeps sending me notifications. Like there's nothing here, dude. Okay, I think I understand that. Yeah.
MQ right now with the architecture, and one is a tremendous amount of flexibility you have moving messages through your system.
We can just say default is
system. In fact, they say you can design your system with whatever you want. The sky's the limit.
I can look this up later. Like if I have an interview, I can say, oh, I looked up things on message queues. Here's what I know versus having to watch a bunch of videos again.
And then later configure RabbitMQ to work with your system, as opposed to needing to know RabbitMQ's limitations and designing your system accordingly. Also, with other message brokers, the broker administrator, when they set up the message model, that's when all the configuration for how a message moves through the system, that's when it's all defined. But with RabbitMQ, the way the message moves through the system is largely a part of the message metadata. So in this case, it's the application and the developer that has a lot of control with the way messages move through the system rather than the broker administrator. Another great benefit to RabbitMQ is that it is cloud friendly. RabbitMQ can do cross-language communication.
Don't care about that.
When a message is in a queue and it goes to the consumer, the message stays in the queue until the consumer lets the broker know that it has received the message. And only then is the message taken out of the queue. And that prevents the system from losing any messages.
So message loss. So RabbitMQ is good because of acknowledgements.
It has great management. So right out of the box, you have a really good browser-based management UI, as well as extensive CLI tools. Not only that, but the open source community has created plugins that really enrich the management and monitoring part of RabbitMQ. And speaking of the open source community, it has created a lot of plugins that can enrich Stomp, AMQP 1.0, for example. So this has been an overview of RabbitMQ.
Cool. That overview was very helpful. RabbitMQ is the broker of choice. I think Redis is a good in-memory data store, like a cache. As a message broker, I haven't seen a lot of cases for that, so I'm not super convinced it's gonna work. We're gonna use Plaid to connect to our bank data. We have to have a front end for logging in. So the service is running on my Docker instance, but I would need to host it outside of Docker, or I would need to host it somewhere like free, like containerize the app. How do you run a RabbitMQ instance somewhere? Just run it? I don't know how you run that either. I don't know. Bow. Okay. So what we discovered today? We discovered hold on. Anyway, choose your hard, bro. It's hard to be broke and it's hard to be rich. Choose your hard. That's what they always say, right? Processing will be a Python app that fetches data and calculates some stuff and sends it over. We haven't crafted the email yet, but we know the architecture for what email we're going to send. We're going to need a broker to connect the services. Now, the reason why I have a broker for this is because I want to learn more about brokers, purely for that fact. I believe that this is a small enough app, especially as an MVP, where I could do a REST request and just be like, hey, over HTTP, over HTTPS, just sending some over HTTP the data. Nothing sensitive is in the response, is in the message. They have to wait for a response to keep moving forward, and that makes sense, right? Processing shouldn't have to wait for a response. But anyway, cool. So Keanu's free tomorrow. Yo, Keanu's free tomorrow? That's the name of his wife. Why is he free tomorrow? Niggas is weird. What was I gonna say? What was I gonna say? Okay, so in this session, what do we accomplish? We are officially using Rabbit MQ as a broker for point-to-point or direct messaging from our processing service to our sender service. Why? Because the requirements are that the sender service needs to succeed. It should acknowledge that it was sent. Don't send it twice. We don't just store anything once it's sent. Delete it. Move forward. Like, it's not that complicated. You know what I'm saying? It's very much like once it's been received, send it over. It's fine. That kind of thing. Okay. What else? What else are we doing? For a processing service, we've agreed on Plaid. We're going to spin up a Docker instance that will allow me to log in and give my service permission to access my data. Then on a cron job, it will reach out to my banking information every single day at a certain time. We'll say 8 a.m. And then it will send me an email saying that it processed everything and here's what you spent in the last 24 hours. Now I can get that data. I mean, it's not hard to do. It's just interesting, I think. So yeah, that's it. I think I will start. Well, let's think more about the email we're gonna send tomorrow, and then we'll start on the actual coding in terms of getting the service set up, and then the RabbitMQ instance, and then the sender service. So assuming Plaid works out fine, that'll be a different session, and yeah, that's it. We done. That was an hour and a half. Oh my God. I read like a freaking 3-year-old. My reading was terrible. Don't judge me.